All right, folks, welcome back to the shop. We got ourselves a 2020 Ford Escape here. Really nice car, like basically in brand new condition. Customer bought this used from a Ford dealer like 3 months ago or something like that. It's got 43,000 miles on it, and they're complaining they're having trouble opening and closing the door. And here's what we found. First, I thought it was just this door stopper or strapper or whatever, which are not too uncommon to see fail, but it's perfect. We open the door up, and here's what we find. We have broken spot welds, or actually it's broken door. The spot welds are good. It's actually the material that the door is made out of is pretty thin and broken. And this is a known issue. If you Google this problem, you've probably Googled this problem and ended up here. This is what happens. So this inner piece is put inside the door and spot welded in at a stamping factory, then sent out to Ford where they're put on, the doors are put on the production line. Here's how we're going to fix it. So according to a technical service bulletin, Ford is well aware that there is a problem. There's two service bulletins, SSM 51553 and SSM 50150. The solution to this problem is the Ford dealer wants to replace your door. Now, one of these doors is going to be a few $1,000s, and then you have to have it painted. Good luck matching this paint color ever. And then you get to put it all back together. I bet you that's a $3,000 job anyways. Contacted our local Ford dealer. They said if they'd bought it there, they would try to get them goodwill on it, as this is a ridiculous failure, and they even agree. However, this customer didn't buy it at the local Ford dealer, so I called the Ford dealer that they bought it off of, and they told me, nope, they have to pay for it because it's beyond, I'm going to say 60,000 kilometers. So basically, thank you for your money, get fucked, is what the dealers are saying. So we're going to fix it here so at least the car will run and drive safely without being too invasive. And then we're going to get the customer, will probably fight with Ford, and Ford should fix this. This is a defect in workmanship and materials. This has nothing to do with customer use. Anyways, show you how we're going to fix it. First thing I'm going to do is take my body shop grinder. This is not for working on engines. This is for grinding down body stuff. I'm going to grind down all of these pieces of the spot weld. Then I'm going to drill them out. The plan is we're going to use a really heavy-duty rivet to hold this in and see how well that works. The perfect world would be to grind these down and re-weld them. However, that is going to make a bigger mess and open us up to corrosion and rust more so than we already have. So I think this is the least invasive way, and we'll see how it holds up. So also from that thing floating around, this bit of tab's been a little flared out, so we're going to body work that on the anvil on the vise and just get it nice and straight. And then what I'm going to try to do is I'm going to center punch where these spot welds all are, because that should get us lined up pretty good. See how that spot weld damn near missed. And that's where our rivets are hopefully maybe going to go. So you see I've center punched all these, and I'm going to come in with a 1/8 drill bit, punch them all out. So I've drilled them all out. Pilot hold, I'm happy with the center, and I'm going to take a 3/16 drill bit and drill them out. Then I'm going to come back with a little countersink and just deburr so everything lays nice and flat. So we got everything deburred nice. When I was drilling this one, because it was almost off the edge, it finished going off the edge, so we're just going to take a file, clean it up, make sure it's round and in the right spot, and then we're going to use a backup washer, at least on that one. I'm probably going to put a backup washer on everything. Stay tuned. Oh, there we go. Maybe, yeah. Cool. These things are called Clecoats. You need them. They are the handiest thing if you're doing any work with rivets. It's 3/16 Clecoat. You work it in there, get special pliers, and that's going to hold everything in place. I put them in everywhere that I'm going to put a rivet, and then I'll take one Cleco out, put the rivet in, take the next Cleco out, etc., etc. It holds everything in place nice and solid while you work with it. So as I work on this, I've actually discovered a couple things and made a couple more decisions. So I've got our first row of rivets in, right? And what's interesting is, see this hole here and this hole here. Well, I don't know if we can see up inside the door very well. Probably can't. Oh, there we go. Do you see how, where those holes are, there's no material on the strike holder or the tether holder? And I suspect that's a part of the process of stamping it, but I suspect it was engineered to have more material there. So really, we've only got 3 spot welds, one of them barely hitting, pardon the focus, that 3 spot welds instead of 5 holding it. And that's those ones there are the ones that take the most amount of load as you're closing the door. These other ones around the corner have more of a shear load, but they still broke too. But probably these ones failed first, and then the thing starts walking back and forth, and then it just metal fatigue. The metal's really thin. So one thing I'm going to do, I can't really get in there. I'm not going to make this a bigger mess than it is. So I'm not adding any more holes to that, which I really wish I could. But you can see those backup washers in place. I've used stainless steel, 3/16 stainless steel rivets, which are kind of a bitch to use, but they give you, I'm going to say, the most clamping force and then the most fatigue resistant. So hopefully this puts an end to this, or at least buys time until Ford comes out with a recall or the dealer takes care of this for the client. But anyways, the other thing I'm going to do is, we've only got 3 holes here. I suspect there should have been a spot weld here. So I'm going to drill and put another hole in there, and I actually might put one here and here, just again to get a little bit closer to there. You know, a little extra isn't going to hurt. So yeah, follow along. So here's another look at those backup washers. They're just an aluminum washer. I get them from All Star Performance. We use them more for like riveting body panels on race cars together, but they're handy in a lot of applications. They're certainly going to add some strength to this. So I'm going to reach around, put that in. Let's say I can't do that with one hand, then we'll rivet that in place. So there we ended up adding 1, 2, 3 extra rivets. I'm really happy with actually how this turned out. And you get an idea from the inside. You know, we'll see how this does. Yeah, I guess maybe I could have put that rivet in a different spot, but hey, it's additional. So let's see how this goes. We'll finish putting her together. And yeah, this is the best we can do other than doing a bunch of welding and turning this into a big mess. The last thing I'm going to do, I'm going to squirt a little bit of this crown inside, and on the outside wipe it in, as you know, that's penetrated the coat and the paint and everything. So this is where rust might want to start. So I can just give it a fighting chance. You know, pretty protected spot. But anyways, that's what we're gonna do. And actually earlier in the video, I thought maybe these extra holes were missed spot welds, but no, they're just spots for this weather stripping clip to go back in. So go easy on the comment section, guys. I'm just trying to understand what happened here. Clearly, I didn't design this junk. There you go.